The next question is one of the important question which has occurred in most of the competitive exams. It is based on the acidity of phenols. I will read the question. The correct order of acidic strength of the following compounds. They have given 4 compounds: phenol, paracresol, metanitrophenol, paranitrophenol. Now, when we come to this, how do we find out the acidic strength? They have given different options. Based on the decreasing order of acidic strength, we have to find out which is more acidic than the other. Now, coming to it, look at the compounds given. It is phenol, paracresol, metanitrophenol and paranitrophenol. Now, phenol, we know it is acidic. Paracresol, cresol is nothing but a phenol containing CH3 group, that is, we have benzene ring, we have OH and CH3 group. So, we have a CH3 group in the second compound. Then metanitrophenol, metanitrophenol is a benzene ring, we have OH, at meta position we have nitro group, and the last one is paranitrophenol. The first one phenol we already know. Now, depending on the electron releasing group and electron withdrawing group, we should decide the acidic strength of the phenol. Now, methyl group is an electron donating group. When an electron donating group is present, what happens? The acidic strength will decrease. Whereas, when an electron withdrawing group is present, then what happens? The acidic strength increases. So, among cresol and phenol, the cresol is less acidic than phenol. So, this comes last, 2 comes last. Now, look at the option, 2 comes last, and almost all the others there is no 2, but we will check for the others as well. Now, coming to metanitrophenol and paranitrophenol, as the group, the distance from OH group increases, what happens? Its effect will decreases, and therefore, metanitrophenol will be more acidic than paranitrophenol. So, when we look at this, what is the option? We have 4 greater than 3 greater than 1 greater than 2. So, you can see that the option A is the correct option, and therefore, option A is correct. So, you have to decide the molecules which is more acidic or which is less acidic based on electron withdrawing group and electron donating group. We may be wondering why metanitrophenol is less acidic than paranitrophenol. Metanitrophenol, though it is very closer to OH group, paranitrophenol, the nitro group is farther away from OH group. There is intermolecular hydrogen bonding. Intermolecular hydrogen bonding is more, and therefore, it will be more acidic. So, paranitrophenol will be more acidic than metanitrophenol, which will be more acidic than phenol, and phenol will be more acidic than cresol. So, option A will be the correct option. The next question is based on the Riemann-Tiemann reaction which we use for synthesis of salicylaldehyde. They may directly ask this question, but sometimes there are different ways of asking the same type of question. Now, we will look at the reaction. The Riemann-Tiemann reaction has been given. We have phenol reacting with chloroform in the presence of NaOH to form the salt of salicylaldehyde, which on hydrolysis will form salicylaldehyde. Now, when you look at the reaction, the question asked is the above transformation proceeds through. They have asked the mechanism of the reaction rather than the reaction. Now, what are the different options? Option A, electrophilic addition. Option B, electrophilic substitution. Option C, activated nucleophilic substitution. Option D, benzene substitution. Now, how do we do this? First, we will try to understand. When chloroform reacts with NaOH, we get an anion, that is CHCl3 will react with NaOH. The NaOH will take away the hydrogen to form CCl3 minus. Now CCl3 will undergo decomposition to form CCl2 dot plus Cl minus. Though it contains electrons, they are electrophilic in nature because this carbon is devoid of 2 more electrons. There are only 6 electrons around this carbon atom, and therefore it is acting as an electrophile. This type of compound, this type of intermediate, we call it as carbene. So the carbene is devoid of 2 electrons and therefore it acts as an electrophile. Now the electrophile is attacking and it should be an electrophilic addition or substitution. But when you look at the reaction, the hydrogen on the benzene ring has been replaced by the carbene group, and therefore the reaction is electrophilic substitution and not electrophilic addition. So the option B is the correct option, electrophilic substitution. Okay, moving on to the next question. The best reagent to convert pent-3-ene-2-ol into pent-3-ene-2-one is. So we have a double bond and an alcoholic group. We have to convert it into a double bond and an one group, the ketonic group. How do we do it? There are 4 different options. Option A, alkaline KMnO4. Option B, acidified dichromate. Option C, chromic anhydride in glacial acetic acid. Option D, pyridium chlorochromate. Now look at the compound. We have pent-3-ene-2-ol, that is CH3C, 5 carbon atoms. We have at third position we have a double bond, and at second position we have an alcoholic group. So this has to be converted to a ketonic group without oxidation of double bond. So without oxidation of double bond, all these are strong oxidizing agent. Even the double bond will be converted to the respective compounds, and therefore the option D is the correct option, that is pyridium chlorochromate. So remember, PCC or pyridium chlorochromate is the compound which can convert only alcoholic group into ketonic group, and double bond will not be disturbed. So if they ask in a different manner also, you should be able to write the end product here. If PCC used, the double bond will not be oxidized. So option D is the correct option, pyridium chlorochromate. Moving on to the next question. What is the end product formed in the following reaction? We have phenyl magnesium bromide reacting with ethylene oxide to form A, which on hydrolysis will form B. Now we have to find out the end product B. The option given are A, phenol, B, ethyl benzene, C, 2-phenyl ethanol, D, benzaldehyde. How do we do it? We know that the phenyl magnesium bromide will attack this carbon atom, and therefore the opening of the chain takes place. So we have phenyl group attacking this carbon to form CH2, CH2, and opening of the chain takes place to form O, which on hydrolysis will form OH. OMgBr would be there, which on hydrolysis will form OH, and therefore it is 2-phenyl, this is 1, 2, so 2-phenyl ethanol is the answer. So look at the option, option C, 2-phenyl ethanol is the correct option. The next question is, among the following compounds which can be dehydrated very easily? There are 4 options given. Option A is a tertiary alcohol, option B is a secondary alcohol, option C and D are primary alcohols. How do we solve this? Now dehydration is nothing but removal of water molecule. So the OH group whatever is there will react with H plus to form OH2 plus. Now this group will be removed from the compound. Now look at the options and determine in which the OH group will be easily removed. We know that the tertiary carbocation is easy to form compared to the other carbocations, and since tertiary carbocation is very stable, we can see that option A is tertiary alcohol and therefore option A will be the correct option. So option A is the correct answer. Now when we look at B, C and D, compare it. B is a secondary alcohol, C and D are primary alcohol. Now removal of OH from the compound will lead to secondary carbocation and primary carbocation. We know according to inductive effect, the tertiary carbocation is more stable than secondary carbocation, which is more stable than primary carbocation, and therefore tertiary carbocation is easily formed. Now since it can be easily formed, dehydrations occur faster in tertiary alcohols compared to the other types of alcohols, and hence option A is the correct option. The next question is, what is the product formed when ethyl bromide is heated with dry silver oxide? Option A ethanol, option B acetone, option C ethanol, option D diethyl ether. Dear students, you already know the reaction between ethyl bromide and silver oxide. So when we heat ethyl bromide with silver oxide, we get diethyl ether. It is a very direct question. Now we will try to understand by writing the reaction. What is ethyl bromide? C2H5Br. This will react with silver oxide, Ag2O. Now what is the reaction that is taking place? 2 molecules of the ethyl bromide will react with silver oxide. Here silver bromide is removed and we get diethyl ether, that is C2H5O C2H5, and the byproduct is AgBr. So this is how ethyl bromide will react with dry silver oxide to form diethyl ether. Now what is the option given here? The option D, diethyl ether, is the correct option. It is a direct question, but you should know what is the reaction. Sometimes they may ask you the reaction itself, they do not give these explanation, just identify A in the following or identify B in the following, something might be asked, then you should be able to find out the reactants or product in the reaction. So this reaction can be asked in the other way also. So option D, diethyl ether, is the correct option. The next question is also a memory based question. Now what they have asked is, the reaction carbon monoxide plus hydrogen will react with hydrogen at high pressure and temperature in the presence of catalyst to give option A HCHO formaldehyde, option B HCOOH formic acid, option C methanol CH3OH, option D ethanol C2H5OH. Now this is a very direct question. about preparation of methanol from water gas. So, it is an industrial preparation of methanol. Huge quantity of methanol can be prepared by using this reaction. So, when you look at the reaction, that is reduction of water gas using hydrogen using a catalyst will always lead to methanol, and you should be careful about the catalyst. Now, when we talk about the catalyst, zinc oxide and chromium oxide will always lead to methanol. A different catalyst will lead to a different product. It can lead to formaldehyde and so on. So, therefore, look at the catalyst properly and then answer. Here chromium oxide and zinc oxide is being used and reduction is done by using hydrogen, and therefore, the water gas will be converted to the methanol. And we know what is water gas. It is nothing but the mixture of carbon monoxide and hydrogen. So, therefore, whether they ask it as reduction of water gas or they give the reaction, we should know that it is the industrial preparation of methanol. Now, look at the options. Option C is methanol, that is nothing but CH3OH. Option C is methanol. So, therefore, option C is the right answer. Moving on to the next question. An ether is more volatile than an alcohol having the same molecular formula. This is due to option A, dipolar character of ethers, option B, alcohols having resonance structures, option C, intermolecular hydrogen bonding in ethers, option D, intermolecular hydrogen bonding in alcohols. Now, it is a very direct question. When we consider alcohols, alcohols have more boiling point compared to ethers. Ethers are very volatile in nature. That means that it can easily vaporize compared to the alcohols. Now, we consider why is it so. When we consider alcohols, alcohols group is OH. We know that the oxygen hydrogen bond, this is delta minus and this is delta plus. There exists polarity between the oxygen and hydrogen bond because oxygen is more electronegative than hydrogen. Now, because of this polarity of the bonds, what happens? It forms hydrogen bond with oxygen of another alcohol which has delta minus and delta plus. This type of bonding you have already seen in water molecule. The hydrogen bond exists between the small positive charge of hydrogen with small negative charge of oxygen, and therefore, a bonding is formed between them, and because of this hydrogen bond, some properties of the compound is changed. Now, what are those properties? We have already understood, like boiling point or the volatility of the compound, all this changes because of hydrogen bonding, and therefore, alcohols will have intermolecular hydrogen bonding, whereas when we consider ethers, ethers will have OCH3, and we know that CH3 group has plus I effect, and though it will be delta minus, there exists no hydrogen which can form hydrogen bonding with one more ether molecule. And since hydrogen bonding does not exist between the ether molecules, there is no intermolecular hydrogen bonding, and hence it is highly volatile in nature. So, alcohols are less volatile because there exists intermolecular hydrogen bonding. Now, if we consider the same for different examples, instead of asking directly ether and alcohol, they may give some compounds. Based on that compounds, you should find out the boiling point. For example, if I say CH3O CH3, CH3 CH2 OH, okay, and similarly CH3 CH2 Br. These three compounds will be given. Which are the three compounds? Diethyl ether, ethanol and ethyl bromide, almost having the same molecular weight and having same number of carbon atoms. When we consider these three compounds, what happens is diethyl, among these three which is more volatile, it is always diethyl ether. Here as molecular weight increases, the next will be ethyl bromide. So, the one which is lesser volatile is diethyl ether, the next will be ethyl bromide, the last one will be CH3OH. So, CH3OH has higher boiling point compared to ethyl bromide, compared to diethyl ether. So, they may ask based on the compounds or they may ask directly as this question. So, therefore, you should be able to understand why alcohols will have higher boiling point compared to corresponding alkyl halides or the corresponding ethers. If you know this, you can answer any of these type of questions. Now, look at the option and tell me the answer. It is nothing but option D, which is intermolecular hydrogen bonding. Intermolecular hydrogen bonding, option D. The next question, catalytic dehydrogenation of primary alcohol gives a option A ketone, option B aldehyde, option C secondary alcohol, option D ester. Now, this is again a direct question, very direct, but you should know the reaction, what is happening. This is actually one of the preparation of aldehyde, or you can consider it as the property of alcohol. So, when we consider this, what happens when alcohol, primary alcohol we can write it as RCH2OH. Now, RCH2OH I can write it as RCHHOH. Dehydrogenation means 2 hydrogen is been removed from the compound. So, when we remove hydrogen molecule from the compound, what is the product that is being formed? RCH, and this becomes double bond O. So, the primary alcohol always gives an aldehyde. Similarly, when we take secondary alcohol, then it will give a ketone. So, you should know what will happen when dehydrogenation takes place. When dehydrogenation takes place, the aldehyde is being formed for primary alcohol. For secondary alcohol, it will be ketone. For tertiary alcohol, it will be an alkene. Actually, this reaction is used for differentiating between primary alcohol, secondary alcohol and tertiary alcohol. And therefore, remember this reaction, whether they ask it for primary, secondary or tertiary, you should be able to write the products. So, primary will give aldehyde, secondary alcohol a ketone and tertiary alcohol an alkene. And now, look at the option, we have primary alcohol undergoing dehydrogenation, and in the options we have aldehyde, which is nothing but option B. So, option B aldehyde is the correct option. The next question is, nitration of anisole gives majorly Option A, nitroanisole. Option B, para-anisole. Option C, ortho-nitroanisole. Option D, meta-nitroanisole. Now this is again a direct question, but still here they have asked the majority product. Now when we are solving this, always remember when an OH group is present or anisole group. Now when we talk about anisole, what is the structure of anisole? It is nothing but the benzene ring with OCH3 group. We know that the OH group or OCH3 group, if it is present, then it is ortho and para directing group. When we consider aldehyde or the ketonic group, the carbonyl groups, they are usually meta directing group. Whereas these groups, the halogens or OH or anything which contains lone pair of electrons on it, you can even consider the amine group, NH2 group. So any compound that may be asked, you should know which is ortho directing group and para directing group. Whereas when you consider the carbonyl compounds, they are meta directing group. So if you know that, you can solve any one which is based on this kind of reaction. So nitration, sulfonation, all these reactions, you should first look at the group which is attached to the benzene ring. So if you know the group and whether it is ortho or para directing group or whether it is meta directing group, then you can easily tell the answer. But when we consider the anisole, it is a bulkier group, CH3 group. If it was OH, we would have got both ortho hydroxy phenol as well as para. Okay, we are nitrating it. So ortho nitrophenol and para nitrophenol we would have got. But when it is an anisole compound, then the OCH3 group is bulkier. When the group is bulkier, it is difficult to nitrate at ortho positions. It is difficult to nitrate at ortho position, and therefore the para position will be nitrated more compared to ortho position. So this will undergo nitration to form para nitroanisole. So whenever you are solving such type of reactions, please find out whether it is ortho directing group or ortho and para directing group or meta directing group. Now we know the reaction. Now looking at the reaction, which is the major product? It is the para nitroanisole. So therefore, which is the correct option? The option B, para nitroanisole is the correct answer. So option B, para nitroanisole is the answer for this reaction.